Hi, welcome to the MoonTech City YouTube channel. Today we are going to review and test TP4056 module used for charging lithium iron and lithium polymer rechargeable batteries. As most of you are aware, this module is well known around the world and very useful module for charging single-cell lithium iron and polymer batteries. In this video, we will discuss every single detail of this module, including key specifications, electrical characteristics, working principles, module connections and pinouts, and features of the module. We will add advantages and limitations of this module too. Here is the TP4056 module we are discussing in whole video today. Looks like a small module with few components. The size of a TP4056 module is approximately 27 mm by 17 mm or 1.1 by 0.67 inches. Though exact dimensions can vary slightly between different versions and manufacturers. First, we will mention main specification given by many manufacturers for this module. Supply voltage is 5 volts DC and cutoff charging level at 4.25 volts. Battery over discharging protection level is 2.5 volts, and battery over current protection is 3 amperes, and maximum current drawn is 1000 milliamperes. If we further explain these specs for your understanding, when we supply 5 volts to this module, the battery connected is charging with maximum 1000 milliampere current, and when the battery becomes 4.25 volts, charging will disable and battery never get overcharged. If we have connected a load to this module, the battery will discharge up to 2.5 volts and disconnect the load. Nominal voltage of a lithium-ion battery is 3.7 volts, and full charge level is 4.2 volts. And also, if the load connected to this module drawn more than 3 amps, the overcurrent protection will activate and disconnect the load. So here is the micro USB connector to supply 5 volts to the module. We can buy module versions with a USB-C charger connector too. We can use terminals here, situated in both sides of the connector, to supply charging voltage. The voltage supplied to these terminals can be 5 volts to 8 volts. Then there are 2 LED bulbs to indicate power on and charging status. When power on, the blue color LED is on, and when the connected battery is charging, the red LED is on. Then, at the other end of the module, we can observe 4 terminals. Middle terminals for connecting the battery, and other terminals are for connecting a load. This is the main IC used in this module. It's called TC4056 or TP4056. Both ICs are same and used to control charging the 3.7 volt lithium batteries. In addition to the main 4056 IC, there are 2 other ICs are installed. One is DW01A protection IC, and other one is FS8205A. That is a dual N-channel MOSFET driver IC. The other important component is this programmable resistor, labeled as R3 and 1.2K value. That is the resistor to control the charging current. Default value is 1.2 kiloohm, and if we increase the value, the charging current is decreased. There are some models we can buy in the market without protection. Here's a module without protection circuit, so only TP4056 IC is available, and DW01A protection IC and 825 MOSFET IC is not included. But charging is same like other modules. Now, we have explained enough details about the physical appearance, and this is the moment to explain functions and operation of these components with the help of datasheets of ICS and a sample full circuit diagram of this module. Now we are going to connect a micro USB cable to this module and test. When we connect the 5 volt supply to this micro USB connector, the blue LED is on and indicates power is on. Now we will connect one 18650 lithium-ion battery to the battery terminals. So we can see red LED is on, while the blue LED is now in off condition. After charging the battery to full level, that is 4.2 volts, again the charging red indicator is off and blue LED is on. That means battery is fully charged and the charging current is stop. Now we will look at the datasheet of TP4056 IC. Datasheet has a detailed description of TP4056 IC, pin connections and key features and absolute maximum ratings. A typical application circuit diagram and details about typical applications also mentioned in datasheet. The values of the programmable resistor to control the current is also in the datasheet. Trickle charge level of the connected battery is noted as 2.9 volts. So when the battery voltage is below 2.9 volts, trickle charge is in function and the charging current is around 130 milliamperes. But after the battery is charged to 2.9 volts, battery is charging with maximum current, and typically it is 1000 milliamperes. But in practically, we can get about 500 to 800 milliamperes due to many reasons. According to complete charge cycle chart in datasheet, the battery will charge from maximum current till the voltage reach up to 4.0 volts. The current is reducing gradually and ceased when the battery voltage becomes 4.2 volts. According to the chart, the time for whole process is also about 2 hours. This is a sample circuit diagram without protection circuit. We can observe the protection IC and MOSFET drivers are not available here. Anyway, today we are discussing about the module with protection. Now we will look at a fully circuit diagram with protection. In this circuit diagram, the red LED and the blue LED is connected via R1 and R2 resistors to the 6 and 7 pins of the 456 IC respectively. Pin 6 is charge pin and 7 is power on pin. Pin 4 and 8 is connected to supply positive terminal, and pin 1 and 3 is connected to supply negative terminal. Programmable IC R3 is connected to pin 2, and pin number 5 of the 456 IC is connected to the battery positive line, and we can observe the load positive is connected to the same pin, and so battery and load positive lines are common. Now when the 5V supply is provided, if battery is not connected, pin 7 is low and the power on blue LED is on. But if we have connected a battery, a current for charging the battery is drawn via the IC, and no 6 pin is getting low and red LED is on. Same time, blue LED is off because the voltage of pin 7 is high. If we want to reduce the maximum current of charging, we should change the resistor value of R3. The typical values are mentioned in data sheet. Default value is 1.2K, and to reduce current, we should increase the resistor value. When we closely monitor the circuit diagram, we can see the minus terminal of the supply voltage is not directly connected to the battery, but connected directly to the load. So normally battery negative and the load negative terminals are connected through FS8205 MOSFET driver only. So if any MOSFET driver is disconnected, the battery and the load connection is also disconnected. Now let's see what happens when the battery is over discharged. The battery voltage level is monitored at pin number 5 of DW01A via R5 resistor. So when the voltage is below 2.9 volts, the over-discharging pin 1 of the protection IC is getting low, and the MOSFET driver connected to the pin 1 is switched off, so the connection between battery and the load is disconnect. So due to the load disconnection, battery is protected from over-discharging, but charging is still working, and the load will be connected again when the battery reaches to 3 volts. The number 2 pin of the DW1A IC is charging current sense input pin, and it sensed the value of the current through the load and battery. If this current is exceeded 3 amperes, the over-discharge pin is getting low, and the MOSFET connected to the pin 3 is disconnect. So again, the connection between the battery and the load is disconnect to protect the battery from overcurrent. So now the function of the complete protection procedure is discussed here, and I hope you will have a better understanding now about how this module is working. Thank you for watching this video, and if you learned something and found this useful, please subscribe my channel and share my video to help to grow my channel. I will continuously upload similar videos and hope you will enjoy them too. Thank you.